The universe is bigger than you think. In 1609, something magical happened. It was a clear night and the sky was beautiful. The stars were shining and sparkling as they always had. But something was about to change. Galileo Galilei had heard that some Dutch spectacles had made a curious optical instrument. A tube fitted at the ends with two lenses, looking through which distant objects appeared closer. As soon as he knew the construction details, Galileo decided himself to perfecting the instrument, managing in a few months to increase its magnification power. However, it was towards the autumn of 1609 that Galileo performed a truly extraordinary act. Driven by scientific curiosity, he directed his perfected instrument towards the sky. The known stars revealed unexpected features, and new stars were added to those of the old Ptolemaic Cosmos. Galileo immediately understood the inestimable value of his telescope discoveries and how they form new observational bases to promote the Copernican doctrine on the motion of the Earth. One of the first things Galileo noticed was that he counted an enormous number of stars, much bigger than he thought it would be, much bigger than a human would have been able to conceive. This powerful instrument basically unlocked an updated version of our universe, offering us a new perspective and eventually changing our vision and understanding forever. Today we're used to telescope images and we know that the universe is really big, but at that time it represented a huge discovery. The stars that we could access with a small telescope were much more than the ones we could see by the naked eye. Some years later, scientists discovered that actually the universe is ultimately made of agglomerates of stars called galaxies, and that we live in one of them, the Milky Way. And as Galileo discovered that the universe was much bigger than he thought, they discovered that it was much bigger than they thought. But how big is it? For example, let's start from the moon. The moon is large in the sky, and the reasons for this could be two. Either it is a close object, or it is a big object far, far away. What astronomers discovered while studying the kinematic and tidal effects of the moon and the sun on the Earth is that actually we are in the first case. The moon is a close object, with the size of about 1/4 of the size of the Earth. Given its size, they understood that the moon must be 250,000 miles or 400,000 kilometers away from the Earth. Often when we see drawings of the Earth and the moon, they look really close together. But don't be fooled. If we take a look at things in scale, though, this is what the Moon-Earth system looks like. The moon definitely seems close because we can see it so well without a telescope. But remember, it's farther away than most people realize. And of course, we can also try to understand how distant are the planets of the solar system. This is soon done if you take into account Kepler's laws. In particular, the third one sets the scale of our solar system, and we find that, for example, the distance of Mars is about 33.9 million miles or 54.6 million kilometers. This is a huge distance. Our mind is tricked and we don't know how to picture such a huge distance because we have no terms of comparison for that. Then in 1920, at the National Academy of Science in Washington, astronomers Shapley and Curtis had a talk on how the universe was according to them based on scientific evidence. According to Shapley, the universe was basically our galaxy, and nothing was outside of the Milky Way. All the stars that we could see, all the planets and nebulae we could spot with our naked eye or telescope must be a part of the Milky Way. Curtis instead believed that the Milky Way was only one of the galaxies out there. This had huge implications because it was setting the scale of the universe to be huge. Today we know that Curtis was right, but at that time things were not so clear, and it was hard to tell who was right or wrong. The problem with this is that measuring distances in the universe is one of the hardest things to do. Astronomers use some well-known techniques based on the distance ladder. What they do is probe the distance of the universe by means of different methods and using different tracers. One of these tracers is the Cepheids, variable stars. These variable stars are very luminous, and their luminosity curve is peculiar. Therefore, they are used as standard candles to measure long distances in the universe. Using the Cepheids, Shapley had obtained a measurement for size of the Milky Way, a really accurate one, similar to the modern measurements. And he also understood that the Sun occupied somehow a peripheral position in the galaxy. So Shapley was really smart, and he was right about a lot of things. But Curtis noticed that with the most powerful telescopes at the time, one could notice some blurry spots, something that they called spiral nebulae. Astronomers didn't know what these objects were. Someone claimed they were balls of gas and dust in our galaxy. But Curtis believed that they were galaxies. Galaxies, just like the one we were living in. And he was pretty convinced of this. The only problem was that if they were actually galaxies hosting thousands and thousands of stars, they must have been far, far away. The answer came when Edwin Hubble found a Cepheid close to one of these nebulae, and the measured distance for this Cepheid, and therefore for the nebula, was something like 700,000 light-years away. According to Hubble, this object, called M31, was a galaxy outside the Milky Way. M31 is nowadays known as the Andromeda Galaxy, and we know that it is only one of the galaxies of our local group. Andromeda is currently colliding with our Milky Way, and in some billions of years, the two galaxies will merge together. One example of a galaxy merger is the antenna galaxies. As you can see, it is pretty clear how these two separated galaxies merged, and now we can appreciate how they form a system that resembles two antennae in shape. So the universe was much bigger than we thought, and Hubble just proved it. But Hubble also found out the universe was actually expanding. This made the universe even bigger. What Hubble found was remarkable. All of the galaxies in the universe appeared to be moving away from our planet. Furthermore, the farther a galaxy was, the faster it was receding. This observation, which Hubble made in 1929, became the basis for what's known as Hubble's law, which states that there is a relationship between the distance of an object in the cosmos is from us and the speed at which it is receding. As of January 2018, measurements from multiple telescopes showed that the rate of expansion of the universe is different depending on where you look. The nearby universe, measured by the Hubble Space Telescope and the Gaia Space Telescope, has a rate of expansion of 45.6 miles per second or 73.5 kilometers per second per megaparsec, while the more distant background universe, measured by the Planck telescope, is a bit slower, expanding at 41.6 miles per second or 67 kilometers per second per megaparsec. A megaparsec is a million parsecs, or about 3.3 million light years, so this is almost unimaginably fast. Basically, the further you go, the faster the objects move away from you, and the universe continues expanding, becoming bigger and bigger. But then, how big is it? Hey, if you're still here watching the video, it means you are passionately curious and want to find out how big our universe actually is. We constantly strive to make videos that excite a curious person like you, so be sure to subscribe now and press the bell notification. Well, to understand how big the universe is, we should make some calculations. First of all, we need to take into account Einstein's general relativity theory, but we also need a good theory for the beginning of the universe. Luckily, we have it. The Big Bang Theory. The Big Bang Theory predicts that we should be able to detect a type of radiation, the oldest radiation in the universe, called the cosmic microwave background. It contains a lot of precious information, and it is essential to understand the age of our universe. In 2013, the European Space Agency's Planck space mission released the most accurate and detailed map ever made of the universe's oldest light. The map revealed that the universe is 13.8 billion years old. Planck calculated the age by studying the cosmic microwave background. The cosmic microwave background light is a traveler from far away and long ago, said Charles Lawrence, the U.S. project scientist for the mission at NASA's Jet Propulsion Laboratory in Pasadena, California. When it arrives, it tells us about the whole history of our universe. Because of the connection between distance and the speed of light, this means scientists can look at a region of space that lies 13.8 billion light years away, right after the Big Bang happened. Like a ship in the empty ocean, astronomers on Earth can turn their telescopes to peer 13.8 billion light years in every direction, which puts Earth inside of an observable sphere with a radius of 13.8 billion light years. The word observable is key. The sphere limits what scientists can see, but not what is there. But though the sphere appears almost 28 billion light years in diameter, it is far larger because the universe is expanding. Thus, while scientists might see a spot that lay 13.8 billion light years from Earth at the time of the Big Bang, the universe has continued to expand over its lifetime. If inflation occurred at a constant rate through the life of the universe, that same spot is 46 billion light years away, making the diameter of the observable universe a sphere around 92 billion light years. What is perhaps even more interesting, though, is what lies beyond the observable universe. The observable universe is all we can currently observe, and it is possible that the rest of the universe outside it be much larger than we imagine. Maybe there are parts of the universe so distant that the light from those places will never reach us, because parts of space very distant from the Earth are moving away from us faster than light. Basically, we will forever be blind to some parts of our universe. Just as a term of comparison, if the observable universe was the size of your fist, the entire universe would be greater than the size of the dwarf planet Pluto. As Stephen Hawking said, the human race is just a chemical scum on a moderate-sized planet, orbiting around a very average star in the outer suburb of one among 100 billion galaxies. We are so insignificant that I can't believe the whole universe exists for our benefit. That would be like saying that you would disappear if I close my eyes. Thanks for watching, everyone. What do you guys think about this video? Let me know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.